Hi students, I need to make an answer key for the chapter 5 review assignment, but I thought that I might as well record me going through it because it might help some students who are having difficulty with this material. So hopefully this helps. It's just me going through the calculation, so it's probably going to be quite boring. And you can skip to the different questions that we answer. Okay, so for number 4, I'm not going to go through it other than just verbally explain how the Avogadro constant, average atomic mass, and molar mass are related. So the Avogadro constant, 6.02 times 10 to the 23, that's what's able to change atomic mass units, AMUs, to grams per moles. So when you have exactly 6.02 times 10 to the 23 of carbon atoms, that is going to weigh the same as its molar mass, 12.01. So if you can if you can write down something based off of that, explaining that in more eloquent words than I am right now, then that would be what I'm looking for. Okay, so let me get I guess I should have gotten my periodic table out, but if we're looking at 13, where are we? There's my periodic table. How many moles of a given substance are present in each sample? So I'm making you do A, C, and E. So A is mass of iron 2 oxide, iron 3 oxide, 0.453 grams. So let's calculate the molar mass. And so I have 55.85 times 2 plus 16. I have 159.70 grams per mole. So when I want to find number of moles, it's mass divided by molar mass. And I always just leave it unitless until my final answer. And I get, okay, so let's follow significant digits. I have 3 significant digits here. So I'm going to use 3 significant digits. So 2.83656, whatever, is going to round to 2.84 times 10 to the minus 3 moles of iron oxide. Now I'm going to color code my answer key because it does actually help me mark. Oh, I didn't want you guys to do B. Let's do C. 1.24 times 10 to the minus 2 grams of chromate or chromium oxide. So I'm going to first calculate my molar mass. 52 times 2 plus 16 times 3, 152. And I get 8.16 times 10 to the minus 5 mole of Cr2O3. Excuse me. So do you see how I'm always showing what it is that I'm solving for? You might have gotten that comment from me. Tell me what you're solving for. You're just putting N or M or whatever. But a lot of students don't write what they're solving for. I don't know why. I guess it's just something other teachers haven't corrected you on yet, but write which variable you're solving for. Okay, so the mass of ammonium bromide is 97.95 grams per mole. And see, now I'm writing N equals 12.3 divided by 97.95. And I get 1.26 times 10 to the minus 1 mole of, okay. And that's all you need to write. Okay, so now we're moving on to number 14. And I guess I'll do my color coding backwards. Number 14A, I have convert each quantity to the amount of moles. Okay, that's so easy because all we're using is Avogadro's number. So I have the number of helium particles. And I want number of moles, so that's number of things divided by Avogadro's. And I get 7.09 times 10 to the minus 3 mole. Oh, I don't want to do red on red. And then we have number of nitrogen dioxide, 5.38 times 10 to the 22 molecules. Okay, so I get that. And then E. Number of formula units of potassium iodide, 1.62 times 10 to the 24 formula units. Oops. I want small n, number of moles of potassium iodide. And I get 2.69 moles, whoops, of potassium iodide. And now we're doing 17. Or did I skip 16? Yeah, I skipped 16. Oh, I don't think I have to. You know what? We'll still do it. We're looking at the molar mass of platinum bromide. So I'll write it out. I have 195.08 plus 2 of 79.90. This is what it works out to. I don't know why my writing is so messy. Anyways, you can think of all the elements kind of like building blocks, Lego blocks, and so we're just combining them in different ways, and then their molar masses change based off of that. So we have 3 calcium, we have 2 phosphorus, and then we have 8 oxygen. I get a grand total of 310.18 grams per mole. Okay, and so now we're on to number 17. Express each quantity as mass in grams. So I have, oh, I want pink. I have number of moles of water, which is 3.70 mole. Their molar mass, this is one that I have memorized, 18.02 grams per mole. So mass is going to be number of moles times molar mass. So 3.7 times 18.02. I get 66 point, okay, let's follow significant digits, 66.7 grams. Let's put it into scientific notation. It's pretty ugly that way, I know. So sometimes, you know, if it's within the hundreds or the tens, we don't tend to always put it into scientific notation, but it's proper form. Okay, C is 14.8 moles of barium chromate, so number of moles of barium chromate, 14.8 moles. The first thing I have to do is calculate the molar mass, and I don't have that one in my head. Let's see, barium is 137.33, number 56 on the periodic table, plus chromium is 52, plus 4 of the oxygen. And so I get a molar mass of 253.33 grams per mole. And so when I want to calculate mass, so see how nothing I'm writing is undefined. Okay, everything that I'm writing, I'm showing you exactly what it is. Okay, so we have 14.8 moles times 253.33. I get 3,749 point whatever. Let's change it. So see, there's only 1, 2, 3 numbers of significance. So 3.75 times, I'm moving my decimal over 1, 2, 3. So 10 to the 3 grams. And my last one, let's do it in green. E. Oh, okay. So now I have molecules of hydrogen chloride. So number of molecules of hydrogen chloride is 9.48 times 10 to the 23 molecules. So the first thing I have to do is change it to number of moles. So that is number of hydrogen chloride over Avogadro's. And so then I get 1.5748 moles. And you might be saying, well, Miss Vella, you aren't following scientific note or significant digits. I don't care until the very last part. So I don't round until I'm all the way done. Okay, so molar mass of hydrogen chloride. I can do this in my head. Okay, and so then the last thing is the mass of hydrogen chloride. So I get 57.415 grams. Again, I'm going to change it to scientific notation and significant digits. So I should only have 3 numbers, and it should be 5.74 times 10 to the 1 grams of HCl. Okay. And then the last one was 19. Let's do it in rainbow. Guys, my level of entertainment in life is which color I'm picking for my answer key. Okay, so how many atoms of fluorine are contained in the number of moles of boron trifluoride? So 0.72 moles of boron trifluoride. Okay, so we can change it. It doesn't matter which step you do here. We can change it to number of moles of fluoride, or we can find out how many molecules first. And I think the way that I taught it to you guys before is, let's do number of boron trifluoride molecules. But since it's multiplication with multiplication, it doesn't really matter. So again, per 1 mole.
Hi, Nicole.
Hi.
What are you doing?
I'm making a video for my students.
Oh.
I'm teaching them how to calculate molecules. This is Frankie, by the way. Do you want to watch me calculate? Are you playing hockey?
Yeah.
Yeah?
Bye, Nicole.
Bye.
I see you soon.
Okay. So I'm multiplying the number of moles by Avogadro's number. So that's my very cute Frankie, my friend's son, who we're helping take care of. Okay, so it's 4.334 times 10 to the 23 molecules. Okay, so in this step, I'm going to change to number of fluoride. And so I need to get rid of molecules. So I'm going to put molecules on the denominator. And then I'm going to put atoms at the top. So in 1 molecule, there are 3 atoms of fluoride. Makes sense, right? So if you have 4.334 times 10 to the 23 molecules of boron trifluoride, then if you want to find out how many atoms, well, there are of fluoride, there are more atoms of fluoride than there are molecules, because the molecule is the bigger entity. The fluoride atoms are the smaller entity. Just like if I said you have $5, how many loonies do you have? We have 5 loonies. Okay, if it was all in quarters, how many quarters do you have? You would have 20 quarters. So you have more, the smaller entities are more numerous than what make up the bigger entity. I hope that actually makes sense, but a lot of students will go, I don't understand how I can have so many more atoms than I do molecules. But it's because molecules are the bigger item and the atoms are the smaller item or entity. Okay, so you multiply it together. Gosh, my house is very lively today. of fluoride. All right. Ooh, I got a coffee delivery. Thank you. What did you do wrong?
Everything.
Okay. All right, guys. I hope that was helpful. Excruciatingly boring. Yes, probably. Let's end it there, and good luck. And hopefully that helped in some small way.